Okay, so in previous chapter we already learned how to factor a polynomial, and most of these questions here, they need that knowledge. So we are not going to waste time, for example, factoring this polynomial, which you already know how to do this. And then we just use this information here. For example, here it says x squared plus 8x minus 20 is these two parentheses. So we use this knowledge. Okay, so what we talked about first, we talked about domain of a function. Okay, so when we have a fraction like this, a over b, we know that any number divided by 0 is, do you remember?
0. No, nothing.
Undefined. Undefined. 0 divided by any number is
0.
0. Okay. So this is a fraction, and we know that on denominator of fraction we should not have 0. Why? Because if you have 0, this happens. The whole fraction is undefined. Correct? So we always should know that the denominator of a fraction should not be 0. So this sign means equality, correct? When we do this, means they are not equal. Means b should not be equal to 0. Okay? So the question says find the domain of the function. Means what value of x this function can accept. When we talk about domain, domain is the values of x that function can accept. So if we want to find the domain of a function, we say first of all, denominator should not be equal to 0. Correct? So now we know denominator should not be equal to 0. So it means if we have f of x equal to x minus 7 divided by x squared plus 8x minus 20, x squared plus 8x minus 20 should not be equal to 0, right? How we find value of x? We factor this polynomial, correct? If we factor this polynomial, we will have this form. And then we say this one is not equal to 0, correct? What zero product says? It says a multiply b equals 0. Means either a is equal to 0 or b is equal to 0, correct? So what happens if we say ab not equal 0? Means a not equal 0, b not equal 0.
So what's like the purpose of these formulas?
This?
Yeah.
Because now we want to say this parenthesis is not equal to 0, this parenthesis is not equal to 0. And x will not be equal to some specific number. Here also x will not be equal to a specific number. So we say x plus 10 should not be equal to 0. Correct? So x minus 2 also should not be equal to 0, right? And then we can solve this. If x plus 10 is not equal 0, means x should not be equal to, bring 10 to the other side, negative 10. X should not be equal to negative 10, correct? And then here, x should not be equal to 2. So this means in denominator here, we should not have negative 10. We should not have 2. Because if we have either of these, denominator becomes 0. And if denominator becomes 0, what happens? Undefined. Correct? So let's replace to see what happens. Instead of x here, let's put negative 10. Power 2 plus 8 multiply negative 10 minus 20. Equal to 0, right? So we don't want negative 10 in denominator because that makes this denominator 0, right? And then let's put 2 also to see what happens if we have 2. So what's the answer? 0. So for both negative 10 and 2, the denominator becomes 0. So we don't want them, right?
Yeah.
So if they ask us what is the domain, what kind of value this function can accept, we will say anything except
negative 10 and 2.
negative 10 and 2. Exactly. So we can accept any number for this function except negative 10 and 2 because just these two numbers make this whole thing undefined, right? So domain will be any x except negative 10 and 2. Correct?
So it's negative 10. Well, it'll be any x except negative 10 and 2. So you can't.
You should explain it well. You should say any x is acceptable except negative 10 and 2. Why we cannot accept negative 10 and 2? Because that makes and the whole thing becomes undefined. Correct? So when I ask you what is the domain of a function, you should find the possible values for x. And here these are the possible value of x except these two, right? Okay. This is a rational expression when we have a function in this form, fractions. And then now we should know how we can use rules to simplify this kind of function. And then at the end, you should be able to find x value and solve any kind of rational expression in a form of equality. Okay, so this is a rule most of you should know by now. It says if we have 2 multiply 3 divide by 5 multiply 3, we can write it down in this form. And we know that 3 divided by 3 is always equal to 1. Right?
Wait, where are you getting those numbers?
This is example.
Oh, okay.
Example for that, I call that rule.
Oh, okay.
So it means we can cancel this and say this is equal to 1. So this is the way we simplify most of fractions, right? And then now we have 2a power 2 minus ab minus b power 2. Divide by a square minus b squared. I said at first, we already learned all the factoring methods in previous chapter, correct? So we are not going to waste time to explain every single kind of polynomial and how we factor them. So a square minus b squared is equal to, do you remember?
Equals AB.
Wait.
A square minus b squared. A square minus b squared can be a form of a parenthesis multiplied to another parenthesis. What is that? Difference of them multiplies to
Oh, A plus B.
a plus b.
Because X plus M, X minus M or something like that. I'm sorry.
This is one of the roots. So that x plus m, x plus n is different,
Oh.
right? So this is the form we can write it down. And then we have 2a squared minus ab minus b squared. So first of all, we see that there is a coefficient for the first square here. And then we know that actually none of them, we cannot find any common factor out of all these terms, correct? These two have common factor, these two have common factor, but all of them, no, you cannot find any common factor. So now look at the coefficient. We have a coefficient for x squared, and we can use this formula. A x squared plus bx plus c, and then we could say find AC, do you remember? And then break down bx, and then you could break down this polynomial to this one. 2a plus b multiplies to a minus b.
That's what it would be if it was factored.
If you factor it, you will get this. And how you factor it? Using this method. AC. Then now we see something in common. In numerator and denominator, we have common things, which is a minus b, right? So we know that a minus b divided by a minus b is 1, correct? So we can cancel them. So these two cancelled, and the answer will be this parenthesis divided by a plus b. And then we cannot simplify more than this anymore. You don't see anything in common. Correct? Do you have any question? So these are some kind of, the only maybe difficult part is to knowing how to factor this polynomial, correct? As soon as you know how to factor this polynomial, you can find the common what is that? Parentheses between denominator and numerator, cancel them, and you can simplify them. Oh, the other example is 2x minus 3y divided by 2x squared minus 7xy plus 6y squared. Okay, so let's actually work on this and factor this polynomial to see how we can factor this as an example. Okay, just as an example and review. So I said, because we don't have anything in common between all of them, we should use one of our method in previous chapter, and the method is this one. Correct? So A is 2, C is 6y squared. Do you see that? Is that correct? We have ax squared, right? And then we have bx, 7y is b, right? And then c will be 6y squared. Am I right? Okay. So I will write down a is 2, b is 7y, c is 6y squared. Correct? So now we will find AC. Means A multiplies C, which is 2 multiplies 6y, right? 12y squared. Correct? Now we will write down the list of factors that multiply together gives us 12y squared. So for example, 12y multiply y gives us y squared, 12y squared, right? And then I will look at the sign of b, and I see sign of b is negative. So what that means? Means both of these numbers should be negative, because if you add them, you should have a negative 7y, right? So either negative 12y, negative y. Correct? Negative 2y, negative 6y, right? What else? 3 and 4, right? Negative 3y, negative 4y multiplied together give us 12y squared, and if we add them together, obviously gives us negative 7y, right? So this one was wrong, this one was wrong, but this one is correct. And if you add them together, you get negative 7y.
Yeah, because you have to get the middle number too.
And then this is these two numbers here will be replaced by, replace this by these two numbers, because you are going to break down this. So you will write down 2x squared minus 4yx minus 3yx. Correct? Because 4yx, 3yx, both of them negative, gives you negative 7yx. You broke down bx, right? And then you have 6y squared. Do you have any questions so far?
Wait, what about the 7?
We broke it.
I'm sorry.
Yeah, we broke down negative 7. And then this one is 2x minus 3y. And then what was the next step? What should I do now? Do you remember? What we call that? Grouping. Correct? Grouping. So let's group these two and group these two. 2x minus 3y. And then we are going to use grouping. So what is common between these two?
2x.
2x. Correct. 2x is common. So we have x minus 2y remains. Correct? What is common between
3y.
3y. So x plus 2y. So here actually I will stop because I want x minus 2y, right? So I think we should change the sign here to make it negative, right? So if we make this negative, this one also should become negative. Correct?
So you can just change it to change it?
No, because you're taking out, instead of positive 3y, you're taking out negative 3y.
You are factoring out negative 3y, correct? So what to do now?
You write down the equation thing, x minus 2y, and then 2x minus 3y, and then...
So we bring out this one,
Yeah.
right? We bring out x minus 2y. So we continue. 2x minus 3y divided by x minus 2y multiplies to 2x minus 3y.
Oh, you divide.
And then those cancel each other out.
Huh? Yes. Cancel them. This one with this one. Why? Because you could put parentheses around them, right? Am I right? So 2x minus 3y could be in parentheses, right?
Wouldn't it be on top you have negative 3y, x negative 2y. Wouldn't that be y squared if you did that?
Oh, because you're
Up on top, the one pushing up. Yeah, the lower one. To the left. Alright. It says negative 3y, x, negative 2y. Wouldn't it just be negative 3 instead of a y? Because you don't have a square on the top. Or is it 6?
Are you talking about this one?
Yeah.
So look at this.
Okay, never mind. I see
Multiply
what
them again.
I did. Yeah. I see what I did.
Yeah, this one had a square, 6y squared, correct?
Okay, I was looking on top for some reason. Okay, never mind.
So, is this correct now? Okay, so we cross out this common, and then what remains on the top?
2x.
No, we cross out whole thing with this whole thing. Nothing is 1.
0 over x
1,
minus 2y.
right? So
Oh, just 1.
this one, imagine it was multiplied to 1, right? Is that correct?
Yeah.
So still we have something, and that is 1 on top, correct? And then what remains here?
X minus 2y.
Exactly. So when you are crossing out, be careful. If nothing remained in top, you should always imagine 1 multiplies to that previous thing.
So only if nothing remains at the top, like an invisible one will be there.
Yes, exactly. Imaginary 1 would be there. Do you have any question? So the next example. 2x squared plus 2x minus 12 divided by x power 3 plus 7x power 2 plus 12x. In factoring out polynomial, the first thing we should find is the common factor between all the terms, right? So as soon as you see 2 in common between all of them, you should factor out that 2, right? As soon as you see x is common between all of these, is that? Yes. You should bring out x. Correct? So 2 multiplies to x squared plus x minus 6. Divide by x multiplies to x squared plus 7. X plus 12. Okay, so we don't have to factor this out because this is the easiest form. We don't have coefficient for x, and we use x plus m multiplied to x plus n. Do you remember? So first you should find m and n. So this is the easiest form, I guess. You should all know. So let's use this. It says x plus 3 multiplied x minus 2. X plus 3 multiplies to x plus 4. Why?
Because it multiplies.
What do you mean why? You're factoring out polynomial, right? So if you factor this, you will get x plus 3 multiply x plus 2. M and n.
She's just factoring that one even more.
You will factor it and you will have this form, right? Is that correct? And then factor this one, you will have x plus 3 multiply x plus 4. M and n. Correct? And then we are going to, what we do now? Cross out which one?
X plus 3.
X plus 3. Right?
Oh yeah, because this.
And then write down the remaining.
2x minus 2
2 multiplies to x minus 2.
over
X multiplies to
x plus 4.
x plus 4.
So, like, if we did have a coefficient for x right there,
You had to use the previous method we were using.
the
AC.
Or yeah, AC. Okay.
Correct? We use ACs first. And then break down B, BX, and then grouping, right? The next question is 25y squared minus 16 x squared divided by 8 x squared minus 14 xy plus 5y squared. So 25 is a complete square, right? 5 multiply 5. 16 is also a complete square, right? So a square minus b square is always equal to, we just had it,
A minus B.
A plus B.
So if you have complete square in first term minus another complete square, 25y squared is a complete square. So what it was 5y, right? 16x squared also was a complete square. It was 4 what? 16x squared was 4x. And then it becomes complete 16x squared, correct? So the first term here will be 5y, correct? And then second term will be 4x. So that's why we can write this 5y minus 4x, 5y plus 4x. you should have a parenthesis around this subtract of these two, addition of these two. Because if you have a parenthesis, it becomes multiplication, correct? If you don't have parenthesis, means you're just multiplying these two middle term, correct? So not having parenthesis will change everything. So this one divide by. We will look at the terms. We cannot bring out anything. There is not common factor between these terms, correct? And we have to use a, x squared plus bx plus c, using AC. And if we use that method, we should get 4x, negative 4x plus 5y multiplied to this. Oh, actually, you know what? No. Look at this. So first you get something like this. So if you factor this one, you will get 4y minus 5y, 4x minus 5y, 2x minus y. And then you will see that the top part is 5y minus 4x, correct?
The other one.
And this one is 4x minus 5y. So they switched, correct? So, oh, sorry, the other one. This one. Okay? So, these are kind of opposite, correct? They switched, right? So now if I factor out a negative sign, let's do this on the top part, because here on the note we have the denominator factor out. So I want something to be kind of different. So 5y minus 4x. Let's bring out a negative sign. If we bring out negative sign, 5y becomes negative 5y. Negative 4x becomes positive x. And then the rest are the same. Nothing changes. Correct? So now I will rearrange these two. I will write down 4x minus 5y. Just rearrange them. Correct? Bring this one first, bring this one to the end. So 5y plus 4x divided by 4x minus 5y, 2x minus y.
Wait, why are we doing this?
To be able to cancel and cross out the similar parentheses. Correct? So now you see the similar parentheses, right? This one is similar to this one. And we can cross them. But if you cross them, don't forget about this negative sign. This was negative 1 multiplied that parenthesis, correct? So you had negative 1 multiplied this parenthesis. So you should keep it. We have negative 1 multiplies to 5y plus 4x divide by 2x minus y. And then you can ignore this and just keep the negative sign, and this is what remains.
can't be factored anymore.
No. The next one is negative 2x plus 14y. Tell me, what is common between these?
2x, or negative, I mean,
2.
2, I'm sorry.
Correct? So x squared minus 5xy minus 14y squared. So now you know, you should bring out 2, negative x plus 7y and then they are saying this one denominator becomes x plus 2y, x minus 7y.
Did they do the ax plus bx thing?
No, this one will be x squared plus bx plus c, and you should find m and n. Correct?
Because, well, there is no coefficient for x.
You want me to solve this? Yeah?
Yes.
X squared minus 5xy minus 14y squared. 7 multiplied 2. Okay. So yeah, we should use m and n. Okay? Because there is other method which says if this one is a square, this one is a square, you should find 2x multiplied y. Do you remember? 2ab plus minus 2ab. So we will see later. That one also will be a kind of good review. Okay, so now here, we should find m and n. We should start with c. C should gives us m multiply n, right? So list all m multiply n. That gives you this one. And then let me write down here. Maybe if you reorder it, actually arrange this one, maybe it will be much easier. So instead of negative 5xy, let's write down negative 5x. And then if we do this, you know this one is b. Correct? Right? X squared plus bx plus c. Compared with this one, so b is 5y, negative 5y. Correct? Okay, m multiply n. We should find two numbers.
7
Negative 7
negative
and
7
2.
and 2.
Negative 7y and negative 2y, negative 7y. Because if you add them together, you will have
No, it's
It's negative 7
positive
and
2.
Positive 2.
Yeah, look, because up there you put positive 2.
Negative 2y multiply negative 7y gives us negative 14y squared. Correct. Right? And then negative 2y minus 7y gives us,
Negative 5y.
so m is this one, n is this one. Correct? So we will write down x plus m x plus, multiply x plus n. X plus m, x plus n. Replace m and n. You will have plus 2y minus 7y. Correct?
Yeah.
Correct. Okay. So which one of these parentheses looks more similar?
Negative x.
Oh, negative y
This
plus
one.
7x and
Minus.
And this one, right? So we should factor out a negative sign to make either of them look like the other one, right? So let's factor out a negative sign here, okay? So 2 multiplies 2, write down negative 1, correct? You are factoring out a negative sign, which is negative 1, correct? Multiplies 2, x, negative x becomes positive x, 7y becomes
negative 7.
negative 7y, correct? And then the first parenthesis is x plus 2y, x minus 7y. And now we see that these are similar, right? And what we can do,
Cancel out x minus 7y.
this one with this one, you have negative 2 divided by x plus 2y. Do you have question? No? Are these clear? I know the most difficult part maybe is to factoring out a polynomial, correct? And this is the most difficult part. So you should be able to factor out polynomial after practicing, over and over. You should be able to do that. It says simplifying the product of 2 or more rational expressions. If we have, look at this. If we have 2 over 5 multiplies 3 over 7, for example, because this is a multiplication, we can put the numerators together. We say 2 multiplies 3 goes on numerator, and this multiplication goes to denominator. We can write it in this form. Okay? If we had, for example, 3 multiplies to 4 divided by, let's say, 2 multiplies to 11, something in this form, we could separate them. Correct? We could separate them and say, okay, 2 divided 3 multiplies to 4 divided by 11. So we can go from this side to this side, or from this form to this form. So we can separate these fractions and we can put them together. So we can use this method to simplify rational expression. Okay. Now we are going to use this method we have 2x power 2 minus 4x divided by. x squared minus 5x plus 6 multiplies to x squared minus 9, 2x power 4, 14x power 3, 24x squared. So we have two fractions. So let us start with the top part of this one. What is similar between these two?
2x.
2x, correct? So we bring out 2x, x minus 2 remains, right? Correct? This one, they are telling us it can be x minus 2 multiply x minus 3, and this is the x plus m multiply x plus n method. So let's write down here x plus m, x plus n. So again, we have a square minus b square. A square minus b square is equal to a minus b multiplies to a plus b, correct? So what is a here? X, right? What is b?
3.
3, right? So we have x minus 3 multiplies to x plus 3. X minus 3 multiplies to x plus 3. Correct? What is common here?
2x
2x or
2x to
to the
2x squared.
2x squared. Here we have x squared, x squared, x squared in all of them, right? Correct? And 2 is common. So 2x power 2 multiplies. The first one remains x power 2. The second one,
7x.
the third one,
12.
12.
Yeah, just 12.
Okay? And then here also, you should continue. This becomes x plus m, x plus n.
Yeah, 4 and 3. Because 4 and 3 is 12. And then 4.
4 multiplied 3 is 12, right? 4 plus 3 is 7.
Yeah.
Correct? So shall we write it down here?
Yes.
It becomes x plus 3, x plus 4. Now, that method I told you, you can put everything together in one whole fraction. We can multiply everything on numerator and put them in one numerator on top part, and then all the denominator multiplies together in here, right? So we can write down 2x multiplies to x minus 2 multiplies to x minus 3, x plus 3. Correct? These are all the numerator we have. We multiply all of them together. Now, denominator is x minus 2, x minus 3, 2x power 2, x plus 3, x plus 4.
You wouldn't write down
Not anymore because we already said this is x plus 3x plus 4, correct? Right? So you cancel the common parenthesis.
x.
Cancel it. So the obvious ones are this one with this one. Am I right?
Yes.
This one with this one. Right? This one with this one. Correct? So let me write down what remains and then we can have another look at them. So now it's more obvious what is in common, right? What is that? 2x in common with 2x here in common. What remains here? Just 1x remains, right? So what remains in top part?
X.
1.
Or
1. 1 divided by x multiplies to x plus 4. Okay?
Yes.
Next question. We have 7x plus 7y divided by 4ax plus 4ay multiplies 8 a power 2 x power 2 minus 8 b power 2 x power 2 divided by 35a x power 3 35b x power 3.
Did you just make that up? Where'd you get it?
Okay, please bring out the common factor from this numerator, and if you have common factor here in denominator, bring out the commons. Here also, bring out the common factor from these two terms too. Okay? So you will have one fraction multiplies to another fraction, and then we will continue. is common between this, right? So you can bring out x cubed, and then a minus b remains, right? Done? Okay. So what is common here? 7.
7x plus y.
What is common here?
4, 8.
4a.
X plus y.
X plus y.
8.
What is common here?
8x squared.
8x squared. What remains?
A squared.
Minus?
B squared.
What is a square minus b square? Come on. 4 or 5 times today.
A minus b, a plus b.
A minus b multiplies to a plus b, correct? Okay. So let's rewrite it, right? Now you know. This is a minus b multiplies to,
Do we have to do that?
yes,
Why?
why not?
Why do you do it?
Because,
But when you
I'm
get
going
the
to
answer,
cancel.
and then you could just put.
tell me.
Well, she's saying like
You
you.
don't need to do
Oh, oh, let's,
Yeah,
let's keep it.
she's saying she's still gonna use that formula, but you don't have to write that down, like in the process of.
Okay, so let's keep it to see what happens, okay? I was thinking maybe I'm going to cancel those.
Yeah, you do.
We do. So if we do, so
Then
we
you
need
just-
a separated parenthesis, correct? No?
You
Okay,
can
let's
just
keep
take
it.
it away. And then
Let's-
you still have 1 left.
I know, you say you can. You know already this is a minus b multiply a plus b. That's why at end you can cancel them out and whatever remains, okay, let's keep it.
Okay.
So this one common is
35x
35.
to the third.
x power 3 multiplies to
A minus b.
a minus b. Okay, so I can do one thing. I can put all of them in one whole fraction all together. Or I can cancel whatever common I see in this first fraction, right? And then whatever common I see in this second fraction, correct? So if I want to cancel, what I will cancel here?
X plus y.
Uh-huh. So what remains? 7 divided by 4a remains, right?
Yes.
From here, let's cancel x squared with this x cubed.
So then it's
Just x.
35x.
35x remains. And then here 8 remains, right? So now we have a squared minus b squared divided by a minus b, and as she said, we know already a minus b is part of this, correct? And if we cancel this one from a minus b, what remains here? A plus b, correct?
Wait.
See, that's why I have to separate. So we know this is already a minus b multiply a plus b. The a minus b cancels with this a minus b. What remains? A plus b remains here. So we cancel this. Then we can write down 7 for a 8 35x a plus b, right? Correct?
Yes.
And then let's put all of them together. 7 a minus b. You don't have to, if you know already what you are canceling, you don't have to do all of this. So from top part and this one, I know 8 and 4 have something in common, correct? This one is 4 multiplied 2. This one is 4. Cancel them. What remains here? 2, correct?
Yes.
Right?
Yes.
35 is 7 multiplied 5, right?
Yes.
Cancel this one and this one. 5 remains,
Wait a minute.
Yeah.
correct? So we have 2 multiplies to this one, which is not cancelled. A multiplies to 5 multiplies to x, correct? Do you see what remains here? So we have 2 multiplies to a plus b, a 5x. We can write down 5ax, correct?
This is a lot of work for one problem.
So, do you have any questions so far? Question?
Wait, so would that be our answer? Or what?
Yes. This is our answer.
Oh. No, we didn't.
So now, let's look at this. So far we had multiplication of 2 fractions, correct? So we had one fraction multiplies to another one, and we said we put all the numerator together and we make it one whole fraction, correct? So what if we have 2 divided by 5 divide by 3 divide by 7? So in this situation, what we do?
Oh yeah.
What we do?
Yeah.
Multiply
you do 2
2.
over 5 times 7 over 3.
Reverse of this one, right?
Yeah.
Reciprocal of this one. So what we do? 2 over 5 multiplies to reciprocal of the second one. Correct? Is that correct?
Yes.
So now we use this and apply this to this kind of rational expression. So we keep the first fraction as it is, 4x squared minus y squared divided by x squared plus 4xy plus 4y. Division turns to the, convert to the multiplication, correct? The second fraction becomes reciprocal, right? So means denominator goes to the numerator, numerator comes to the denominator. Correct? So now you have something exact same as before, whatever we have done, right? From here, can we bring out anything?
2x.
No.
No?
4x squared minus y squared.
You can bring down 4x.
How? 4x is not common between these two,
Oh,
right?
well, there's nothing.
So what should I
common.
write down?
1.
No.
No, it's just 2. No, it's not.
But there's no, they don't have a.
Yeah, it would be.
Nothing?
Nothing.
Yeah,
How we factor this? For what?
X minus 2.
One hint. The first one is the complete square. The second one is complete square.
2x.
You have a square minus b square 6 times today.
A minus b, A minus b, A plus b.
What is a here?
A is 4. Oh.
Don't ruin it.
2x.
2 what? 2x.
Wait, didn't we just say that? I swear we just said that.
She did.
2 you said 2x.
Everybody was saying it. You're not listening.
No! You said we bring out 2x. No, I said this 2x is not common between these two.
Oh, we were thinking of like when you do like 2x and then you.
You should
out
say
a
it
one.
completely. You should say 2x minus what? Now say it.
2x plus y and 2x minus y.
Now
Yes.
it's
That's
correct.
what we were trying
That's-
to tell you.
Next time, try to tell me the complete form. Right?
My goodness.
Hey.
Shut up, Mari.
All of these are recorded on camera. So what this becomes? 3x plus 6y, what do you bring out? 3.
3.
What remains?
X plus 2. Y.
Correct? And then, so this one, I'm not going to, we are going to use this. I'm not going to break this down. X plus 2y, x plus 2y. So work on this later to see how it becomes x plus 2y, x plus 2y. Okay? And then, what? Okay, yeah. So what we bring out here?
2.
2 what?
2x.
2x.
2. That's what I
Multiplies
said.
2x minus.
Minus y. That's what I said. Why are you giving me that look?
No, I didn't give you that look. I was looking at camera. Sorry, I have this kind of students. Okay, so what we have 2x minus y multiplies to 2x plus y multiplies to 3x plus 2y, and then denominator x plus 2y, x plus 2y, 2x minus y. Be careful here because some of them, they look alike, but I mean, you think they are similar, but they are not similar. So what are the similar ones?
2x plus y and x. Wait, 2x minus
X
See,
plus,
they
X
are-
plus 2y.
They are almost the same. Correct?
X plus 2y.
You write it down and then tell me the final cross out.
That one. 2x minus y and 2x minus y.
Yeah.
This one
Yeah.
and this one.
And then X plus 2y and X plus 2y.
Hey, where
Is that correct?
There we go.
Correct? Okay. So the top part 3 remains with 2x plus y, and denominator we have 2x plus 2y, right? X plus 2y. Okay. So now we have 5 more minutes. I want to explain the lowest common denominator, and then later we'll continue solving problems, okay? Least common denominator.
Oh yeah, was that the answer?
Yes.
Oh.
That would be the
Stop being mean to me. Such a bully.
So, LCD. Let's say we have 2 divided by 15 multiplies to, not multiplies, sorry. And we have 5 divided by 20. 20. So now, the first step to break down these denominators to the lowest factor, up to the prime number. So 15 is 3 multiplies to 5. Correct? Then 5 is 4 multiply 5, right? Then write down all the common and uncommon factors between this one and this one. We are finding lowest common denominator, okay? We are talking about denominators here, right? We are going to list all the common and uncommon factors between these two denominators. Common is 5, correct? Multiplies to. Uncommon is 3. Another uncommon is 4. This will be the lowest common denominator. Multiply all of them. 3 multiply 4 is 12. Multiplies to 5 is 60. So LCD will be 60. Now, let's say we have 2 over 50. 5 multiplied 2 and 3 over 20.
That would be 2 over 10 times 5.
20 we already know it's 4 multiply 5, correct?
Yes.
2 divided by
10 times 5.
10 times 5 is 5 multiply 2. 10 is 5 multiply 2, correct? So it will be 5 multiplies 2 multiplies to 5, because 10 multiplies 5 gives us 50.
Okay.
Correct?
Yeah.
Multiply this. 5 multiply 2 multiply 5 gives you 50. Correct?
Yeah. But how come you did it with just 10?
Yeah.
Because I said break them down to the lowest factor up to the prime number. 2 is prime number, 5 is prime number. You cannot break down more, right? We can break down these two. 2 power 2. 2 times 2. Correct?
So the least common denominator is 50?
Let's see. We said write down all the common and uncommon factors. 5 is common, 2 is common. Correct? But we are not done yet. Because here we had 2 multiplies 5 power 2, because 5 multiply 5 means we have 2 of them, right?
Yeah.
The power of 5 is 2, correct? And here we could write down 2 power 2 multiply 5, right? Is that correct?
Yes.
So between these two, which of these has the highest power?
5 squared.
Between 2 and 2 power 2.
2 power
Which
2.
one has the highest?
2 power 2.
So the highest power is 2, right? So choose the 2 with the highest power. And then you will do the same thing to 5. Choose the 5 with the highest power.
So 5.
5 power 2. Correct? And then you will have 25 multiplies to 4, which is
100.
LCD. So what we do, first of all, we break down all the denominators to the lowest factor, prime factor, correct?
Yes.
Then we list and write down all the common and uncommon factors, correct? And then we will choose the highest degree of common or uncommon factor, correct?
Yep.
So either common or uncommon, we choose the highest power of that number. Like here, we choose the highest power of 5, highest power of 2. And actually here, look at this. We should break this down to 2. Multiplies to 2, correct? We should break this down to 2 multiplies to 2. And that's why we chose the highest power of 2, which was 2, correct? Right? Do you have any question? Okay. We'll see you on Wednesday to continue finding LCD and also solving rational expression. Okay?
Yeah, do you want chips? Can we go get some?